do have SpaceClaim up right now, and to kind of summarize what we're going to show today, there's interest in both Discovery Live and Discovery SpaceClaim. For anyone that is really new to the Ansys Discovery portfolio, if you've seen SpaceClaim but not Live, if you've seen Live but not SpaceClaim, you'll notice that the two programs are very similar. This is SpaceClaim right here. You've got the friendly ribbon bar of tools and paneling, and if you look at Discovery Live, it's actually very similar. You'll find the same tools are across the top, but this UI here for Discovery Live has been optimized for simulation, for the real-time upfront simulation. So what I'm going to do is start off by showing you what it's like to design from scratch. I know a lot of you may be familiar with feature-based CAD tools like SolidWorks to create your models, but Discovery Live and Discovery SpaceClaim do it without features. There's no feature tree in SpaceClaim, which means I can edit parts from any other CAD system. I can open up Parasolid and Step and SolidWorks and whatnot and edit them pretty much in a similar way to how I create them. The difference here with Discovery Live versus SpaceClaim is you could have simulation running while you're designing. So for example, I'm just going to sketch out a very basic shape here. And the main tool to create and edit in either Live or SpaceClaim is this tool called Pull. Pull is going to allow me to select one of these faces I just sketched out and simply drag with my mouse to pull it into a solid. Now, when I'm creating this, I may not know what the dimension is that I want, but maybe I have an idea in my mind of what it should look like, and so I can let go, and then I can always round that off to a standard value. But if I know what size it should be, I can select as many faces as I want and type in that exact value to start. Now, you'll notice here that this is an area where you may see or be used to something called a feature tree, but SpaceClaim doesn't have features. So what does that mean? How do I edit a model? If I want to change where this face is, I pull it. If I want to change where this face is, I pull it. Any of these faces I want to change, I simply select and drag. When I do that, the first thing I'm given is a dimension for how much I want to change it by. We have a lot of users that need to add on a certain amount for one reason or another. Other users want to set up a dimension somewhere else. So whenever you click on a face, you get this little menu of common commands. One is called the ruler. I could dimension from anything I see here. I could dimension from the world origin, from the front of this cylinder, from a point, from the axis, from the end. I could even just snap it to a random point in space if there's nothing good to reference there too. But the point is that I can set up these dimensions. But, editing this one face isn't really that impressive. Where, SpaceClaim and Discovery Live really shine is editing multiple things, taking both these faces, changing them together, 2 faces, 3, 4, it doesn't matter. It updates based on the geometry that's there. The same is true for the cylinder. If I go ahead and pull that bigger, I can change the size, type in an exact value if I want, because I didn't know I needed it 25 at first, but that looks like the right size. But now, something different is going to happen at the end here. As I pull this face down, it's either going to sharpen to an edge or I can pull it back and remove. In most CAD programs, there's one tool to add, another tool to cut. Here I'm just pulling it in one direction or another. But, that's just one thing that can happen. Maybe I don't want that to happen. So the primary way to change the behavior is to change your selection. Direct modeling is very hands-on, so, why look through options? Interact with the model instead. So by selecting this face, holding Control, and double-clicking this edge, it grabs that entire loop, and I let go of Control and drag, and now you'll notice that by selecting the edges, it's ignoring the faces. Whenever I pull on a face, it tries to either extend or trim the neighboring faces that are there. But if I also select an edge just by holding Control, we've stolen a lot of shortcuts from Microsoft. So, many thanks to Bill Gates for all those great shortcuts for us to reuse, because I'm sure many of you have used an Office product, which means you're already familiar with how to use a Discovery product. So there I was able to select that edge and make a cut. And you'll notice there's a lot of things I can do directly to the geometry to make changes however I need to, but sometimes I may want to, create something new. So I could always take another sketch tool and sketch directly on a face. Notice that I didn't set up any datums or anything like that, and I just hit P for pull, and I could immediately create a pin or a hole. I could also think outside the box. Maybe I want to edit this face instead, leaving a hole behind or leaving a pin behind. So you can really, design how you think and not necessarily how the features are limiting you. If I can extend this, I can change it, and if at the end of the day I realize it should be a hole, very easy to make that change. Now, I get to a point in my design and I actually wish this cutout wasn't here. There's no feature tree, so, we're not going to change it that way. I do have an undo history up here, but this is only saved in the RAM. This isn't really part of the file. So, if I undo, it's going to do undo in order. I cannot just pick and choose. It's going to undo all the way back to where I want to go. So undo isn't always the best method. Sometimes the best way to go back is to move forward. If I take this face here and pull it and snap it up to this edge over here, well, if SpaceClaim doesn't remember that there was a cut there, so if I want to go ahead and edit it, it acts like it did before. So, moving forward with SpaceClaim is very easy. Sometimes you move forward to move back, changing the size of this hole, just like I did the pin earlier, or maybe it's in the wrong location. So I talked about this tool called pull. Our other main tool to create and edit is called move. Move allows me to take this face and pick a direction, and now I can move it in that direction. If I hold Alt on my keyboard, it puts these little wedges between two axes, and I can drag that around, just throw it here, throw it there, place it wherever I want. Or I can take one of these curved arrows and rotate this hole. So instead of setting up datums at weird angles and figuring out exactly how, you should extrude that in the first place, just throw it in wherever you need it to go and then rotate it to the angle that you need. And, you could always rotate about a different point. If I want to lock in that point of the edge, I could just drag my move tool to there and rotate about there. And what's nice is, we saw the pull tool has dimensions, so does move. Here it's telling me how much I'm moving it. So if I want to move it 1 millimeter, that's good. I can also set up dimensions exactly to something else like this face here. So that should be exactly 5 millimeters easy to do. And we don't like to constrain you or lock you down initially. We want you to be able to move this face later or move this face later. But if you need to move them both, if you want to constrain them together, most constraints are based on selection. So if I take these two faces and select them both, I can translate them together. I can also rotate them together. I can also change where I'm rotating about. Maybe I want to rotate it and lock in this edge at the top. So I put my move handle there, and now I'm rotating about there. But, maybe I realize that for my design, or maybe even manufacturing, I need to keep these two faces perpendicular. So just select that face because they already are, and now I can go ahead and make that change. And, it ends up at getting too thick or too thin. Maybe I can resolve that by maintaining parallelism to the bottom face. So they already are parallel, so that's just a selection. Now they're going to go ahead and update together. But, as I get to this point, I realize a lot of things are changing, maybe too much. Maybe I don't want that hole to move. So I could easily put the move handle on that hole, and now I'm going to be rotating about there. And at the end of the day, maybe I actually don't want this face to rotate, and maybe this is the type of change that I want to make. So, design exploration is really easy with Discovery because, you can do things like take edges and move those. I could just grab this edge and move that up and down. If that hole needs to stay in proximity, I could go ahead and grab that and move that as well. There's so many things you can do with the geometry. The pull tool with faces takes it and basically offsets it or extrudes it. But it also can do other things. If I select an edge, the default thing that happens when you pull on an edge is it creates a round. Of course, we can add, multiple rounds to the model. We can grab chains of edges and add rounds there. Or, I didn't grab the whole selection. I could undo and grab the whole loop and go ahead and round that there. Of course, I can, undo, but we also have a great tool called Fill, which is designed to simplify models by removing things like rounds, and I'll show you that on some more complex models. But, as I get to this point in the model, I don't know how big this thing is. I might want to control some dimensions, like the overall size. So I didn't include any dimension of overall size. I just roughed out a rectangle and a circle and started making changes. But I can go and add dimensions now that I can use to change the model. In Discovery Live, we have a keyboard shortcut for it. In SpaceClaim, it's found under the Details tab. And that's because Discovery SpaceClaim can handle drawing sheets. Discovery Live is not currently designed for that, so you won't find that tab, but you can shortcut this dimension tool. The tool I'm using here is this dimension tool in the Detail tab. And so what you'll notice is if I click an edge, it gives me the dimension of that edge. If I click between these two that are parallel, it gives me the distance. If they're not parallel, it gives me the angle. If it's a round, it gives me the radius. If it's a cylinder, it gives me diameter. So I can either do the edge for the radius, the face for the diameter. Notice that if I click on the front face here and then click near the front of the cylinder, it gives me that minimum dimension. Just rotate to the bottom here. I could click on this face and then click towards the center of the cylinder and I get the center line distance. Or I can click towards the end and get the maximum. So I've got all these great dimensions here. Maybe I'll just go ahead and move them around just a tad. And so, what use are of these dimensions? Let's say I turn on pull and I grab this face and I start pulling. Well, you'll see that some dimensions, their value don't change, obviously, and some dimensions, they obviously do. So as I'm pulling this face, the distance to the cylinder changes, and if I want to use one of these dimensions to drive that pull, there's a little spark that appears. So if I want the distance from this face to the center line to be exactly 70, with the face being pulled, I click on the spark and type in a number, and it resolves to that size. I could pull on this cylinder. Notice that when I pull on the cylinder, the center line dimension obviously doesn't change because the center line isn't changing, but that max and min is. So if I wanted this min to be something like 45, I could type that in and it pulls on that cylinder till the distance between the cylinder and that face that I told it to drive with reaches 45. I can also do this with multiple faces simultaneously. Notice that when I pull both of these faces, the minimum isn't changing. That's staying together because they're both offsetting by the same amount. But the midline is changing and also the maximum. So if I was trying to get this to be exactly 100, I could go ahead and pull, and it's going to offset the cylinder and this face the same amount simultaneously until it iterates down or up to a value of 100. So these are measurements that I put on the model that had nothing to do with the way I defined it, but now they're introducing, model-based definition, if you will. It's introducing these parameters that you can use to drive the model, and that can be anything from a pull to a move. Notice that when I move this, it maintains tangency to those neighboring faces. Notice the angle of those two faces change, and that's great. We typically want something like that to happen. And so I could say move this cylinder in this direction till that center line comes back to 100 or whatever value I need. So parameters, they often say that direct modeling is not parametric, but the real truth is that direct modeling is more parametric than typical feature-based modeling, because you can only use the parameters that you initially added to those features. I could add any parameter. For example, if I care about the surface area of this face, when I pull this face up and down, you could imagine that the surface area is changing. And over on the left in Discovery Live, there's this options panel. And inside of this options panel is a measure tool. And so if I set up what I'm trying to pull, like this face here, and then I take a measurement like the surface area of this face, I can click on it and now drive it. If I type in 6,000, it'll drive it down to that value. And by the way, if you want to do a parametric study here in Discovery Live, or in, through Workbench and Mechanical and any of the other Ansys products, this P button should be very interesting to you because this P saves parameters. They go in this area over here called groups, where I now have this group, and this parameter is, height based on surface area. So this is a pretty advanced parameter there. But even these other ones that I did, where we pulled on, say, this cylinder and this space here, and drove it with this value here, if I hit enter, that P shows up and I can click it, and then I have, we'll just call this the length. And so I've got two parameters there. If I pass this model, and by the way, this is true either here in Discovery Live or in SpaceClaim. If I were to create, something here in SpaceClaim and just turn that into a solid, the interface is the same. I've got that P there and I can click it. I can set up a ruler dimension. Anytime you see that P, that's a parameter you could save. It just happens to be on the left in Discovery SpaceClaim, while in Live it's on the right. But basically, same set of parameters that you can create. The dimension tool would allow you to create the same thing here in SpaceClaim, and the setup, the interface, the interaction is very similar. So you can either use the P that shows up there. There's also a Create Groups button here, which if that P doesn't show up, you could always use that Create Groups button. So, the point here is that you can add whatever parameter you want. You can drive the model however you see fit. You can even use mass properties to drive the model. So if you want to do it by mass, you actually have to do it in SpaceClaim. If you want to do it by volume, you can do it in either. The reason for that is models need a material property set here for volume. So for example, I want to maybe pull this face up. And actually, before I do that, one of the great options with pull here is called copy edge. If I switch to copy edge, it either allows me to copy down, and that gives me a new set of faces that I can go ahead and pull. Here I'm scrolling my mouse wheel to select hidden faces, and I could offset that in. I can also, with this option, here I'm double clicking. Double clicking is very popular in SpaceClaim. It allows you to select loops of things. And if I switch to this direction, I could also copy in that way. Now I have new geometry that I can pull up or pull down, maybe to, add some coring. So one great way to reuse geometry that you already have is with the pull tool, using edges and copy edge, picking the right direction, and then pulling that in. So you'll notice that all of this geometry was created with just sketching a rectangle and a circle, and the rest here was done with pulling. But maybe what I want to do is I want to, pull on this face, changing the mass or changing the volume. So I say that I want to pull this face, and instead of using this measure tool, we have this tool called mass properties. So I can select the body. It's going to give me the volume or surface area. If I specify a material on the side here, I'll now have mass, and I could drive this down. If I needed to keep this under 30, I could type that in, or 25, whatever value I enter, it's going to pull that down until that measurement reaches that value. So this is a great way to drive a model to a certain parameter, whether it's a parameter based on measurements or volume or anything like that. So a lot of what I've showed here is, great for creating models from scratch, obviously. I'd like to show here, taking this and applying some simulation to it. For example, what if I were to put a hole here, and let's just go ahead and move this around. Let's move this up to the face here to center it that way, and we'll move this up to the face to center it that way. So using the up to command and faces will center, something that can be pretty useful. So let's go ahead and add some simulation to this. So we're here in Live, and anytime you want to add simulation to your design, you want to create a solution. Discovery Live currently can do 4 independent types of physics. It can do a thermal study, it can do fluid behavior, both internal and external, it can do static structural, and we can also look at modal. Now, there are certain limitations, we'll call them for now. For example, structural only does linear materials and bonded contacts. Different types of materials and contacts, conjugate heat transfer, combining thermal and fluids is on our future roadmap. It is something we're working on, so, keep your eyes open for future releases to see more of this. I would say that every single point release of Discovery Live has had phenomenally new functionality. So you will get something new in every release. But let's say we're going ahead and set up a structural simulation here. Everything is very hands-on and interactive. If this space here is going to be fixed, I can just select it and look through these different types of inputs or boundary conditions that I can apply. For example, a fixed support. Over on this hole, maybe that's where a load is going to be applied. So, it could be a moment, a number of other things, a pressure, but here we're going to do a force. And I can go ahead and, look at that force. And, I happen to want this to be in Z. And so we'll do 100 up in Z. And you wait just a few seconds. You can barely take a breath. And you've got simulation results. So, let's kind of understand exactly what we're looking at here. So I've applied a fixed condition and a load, and here we're looking at von Mises stress. So, we have a high concentration here, not too surprising. We may also care about what the deformation or the deflection is. So here I can look at this results panel across the bottom, and I've got this deformation here. This may be exaggerated. We want you to see it, so there is an option here to look at what the true deformation would be. And of course, there's also a value here in the tree. Now, we may care about, improving the model. So I may care what changes I'm making have, what kind of impact that has. So we can chart that out. I probably want to reduce stress, so I can go ahead and chart out what the stresses are going to look like. I might want to also reduce deformation, so I can chart that out as well. And, I could probably improve these very well, but at a cost, either cost to, mass or volume. So why don't we also chart that out, total volume. So I can go ahead and, create that there as well. So, let's say I make a change to the model. Let's say I decide I want to, add something to the model like a rib. So if I select these two faces and just turn on my line tool, I'll be looking at this model in a cross section, and you can also turn off the results display to make that a little easier. I could go ahead and just sketch out, somewhere in here. It doesn't have to be exact, and then I can switch back to my pull tool. And there's a nice option to pull symmetrically here, and that'll go ahead and thicken that, and that's merged into the model. And if we just show the results again, we could see that's already being considered part of the new design, and I can see that design change update here in the tree or in my charts. So I can see, the impact of adding this rib. Obviously, the volume went up. Not surprising, the deformation and stress went down. And if I want to, try out different things, I have the option to pause the simulation. Maybe I want to try out a few things. What if I were to, take these faces and pull them inward, making it thinner, but then I were to take this face and pull that outward. So maybe trying to, maintain the volume, but see if that has any impact on the stress or deformation. So I can see, what these ideas, what kind of impact they have. And so if it's just, a few ideas like this, it's really easy to just change it, look at the chart, move forward with the design. However, you might have a variety of iterations to look at. Maybe you're curious what happens if you change the size of this diameter, also maybe changing the thickness here, what impact does that have? So, let's try that out. Well, maybe we want to do a parameter study. So let's go ahead. I'm going to set up a few parameters. I'm going to put a dimension on our rib here, and I'm also going to just pull that down to 2. 2 is a good starting point, so let's add that there. And maybe I also want to set up a dimension, you know, maybe there to there. Maybe we'll just use that value. That looks good. And so maybe we'll start that down at, that's 18. Maybe we'll start it at 15. And that'll be a good starting point. So we'll go ahead and save that. So right now, we've got a few different parameters. I'm going to delete this one. I don't want to use this one for the study. I'm fine with the height. I'm fine with the overall size of this. What I want to do is study, you know, the size of this rib. I also want to study the thickness of this rib. So we'll go ahead and set that up there. So that P is having trouble showing just because it's on top of that. So here I'm just going to use this create group button. So this was thickness of the rib. And then this was, switch this up to rib height. And let's also set one up for the height here. So we'll set up a dimension. And I'm going to start this one off, round that right up to 9. So that's a little higher there. And then let's also do this cylinder. So we'll leave this cylinder as is, and we'll parameterize that. So this is going to be just the base height, and this is going to be the cylinder. So I've set up a few different parameters, things I want to study. I don't want to have to make a bunch of changes and follow these charts here. I want to gain a better understanding of how they all relate to each other. So in the recent release of Discovery Live, we have this new functionality for a parameter study. So I'm going to go ahead and turn that on, and it creates this window here. And we start by adding in the parameters that we want to study. So there was, you know, the thickness of the rib. Here we have, we'll start at, let's say, 15. Maybe we'll go up to 17 with 3 steps. Keep in mind, I'm just keeping these numbers on the lower end because this will take some time to run, and we want to, you know, make the best use of our time here. You could set this up for, you know, 15 to 25 and, you know, run it at every ½ millimeter, something like that. But here I'm going to go with the rib height. And we'll start that off at 2 and go to 4, and we'll do that in 3 steps as well. And then we'll add in the base height. We're going to go from 9 to 11 in 3 steps as well, so just keeping it to 3 steps. And one last one, we'll do that cylinder. We'll start it at 27.5, go up to 29.5, again with 3 steps. In order to run through not just these 3 configurations, but all of them, we click this checkbox right there. And what you'll notice is it's going to run through each one of those, and it's going to calculate these values. Now, in addition to adding parameters that are geometric, you could also add parameters from the side here. The one that you cannot currently is material. That's something that'll be in the future. But if we wanted to see how this this ran with a couple different forces, you can do that as well. I could add a parameter and then just select from right here, and I can use force. If I want to see how a range of forces apply, I could do that, but we're going to cancel that there. Now, in order for this just to go a bit quicker, one thing I haven't really talked about is fidelity. On a simple model like this, you do not need to increase the fidelity, but on large models with lots of detail, in order to capture that fidelity and the detail, you do want to slide this up a little bit. So I'm just going to go ahead and slide that down a little bit. And one thing you'll notice is you can often see the simulation body compared to the CAD. If I drop this down lower, it kind of gets a little farther away. If I make this higher fidelity, you'll notice it gets a lot closer. So that is really what the fidelity slider is doing. But let's go ahead and hit start here. And so it starts calculating these outs. And as soon as it does, it starts to make this chart here. So it's charting out all of those different design points. It's calculating max stress, deformation, and total volume. And right now we're looking at stress in X and deformation in Y. You know, there's a variety of things I could look at, like total volume versus deformation, you know, maybe total volume versus max stress. You know, so I can start to look for trends in the model. Initially, we saw, you know, max stress versus deformation. And what we can do is highlight based on something. Here it's highlighting based on total volume. So the ones in green have a lower volume and the ones in red have a higher volume. So you can start to look for trends in that. Or, you know, maybe I'm curious how the different rib thicknesses trend out. So by turning on rib thickness for the highlight, all the ones in green are one rib thickness, all the ones in yellow are another rib thickness, and once it gets down to the next value of rib thicknesses, those will be another color. So here, I mean, you know, it's gone through 45 design points already, and, you know, I can start to understand, you know, some trends, some ideas. This gives me a much better idea for the model I should send through, you know, typical Ansys solvers in order to validate. The thing with Discovery Live, it is not meant to validate. If you have one design and you want to know if that design is going to fail, you do typically want to use, you know, Ansys Mechanical and Fluent and, you know, Workbench and the typical legacy products. If you're trying to rough out ideas and compare a few different ideas to each other, that is where Discovery Live comes into play. You know, I can go ahead and, you know, see what this design point is. This chart here can be saved out to, you know, an Excel file. And what's nice is that this data, this chart, will get saved with the file. If you've used Discovery Live previously, you know that the actual simulation and results aren't really saved. You load it up and then it reprocesses and then you can work from there. But with this optimization or this parametric study, these values do get saved, so you don't have to run it every time you open it up. And now you can see, you know, these different trends. So if I want to, you know, maybe I want to look at, you know, total volume versus stress, I can start to see those trends there. You know, maybe looking at, you know, rib thickness to highlight. And so, you know, here I can start to look, all right, these are the lower volume ones. Let me maybe look there, et cetera. And you could always, you know, swap these around, looking in different directions. So, you know, as Ryan mentioned, if there are any questions, please go ahead and throw them either into, you know, the Q&A or the chat panel. We're definitely happy to answer any. You know, in terms of what I'm going to do next here, I'm going to switch over to SpaceClaim and talk more about some, you know, geometry prep for, you know, traditional simulation. You know, if you do have any questions about Live and what it's capable of, you know, we can definitely get more into that. The Live does have a lot of great example models. So if you are, you know, concerned with external aero, which I'm sure you must be, you know, it's pretty easy to load a model in and start to get some results. Across the bottom here, what's really useful for external aero is one on the right in the display here, changing that to gradient. It often looks a lot better. Also, across the bottom, you know, you've got different things you can look at. Here we're looking at a velocity profile, but you can turn on streamlines, and the streamlines can be moved around, either up or down, left or right, you know, wherever I want them to go. And there's even particles, and probably the best tip that I have for you with particles is when you look at it like this, it could often be a little overwhelming. this button right here sets up an emitter, like a smoke wand, and just like the streamlines, you can go ahead and position them wherever you want, and start to get a visual understanding of how that flow is going to be. And fluids in Discovery Live is not just visuals. There's also numerics. The same type of charts can be set up. By the way, you'll see the kind of standard basic charts here. If you need something more advanced, just click more, and then you can really pick from a lot of different types of operators and how you're going, what you're measuring off of, like a face or a point. But here, if I'm just concerned with, say, the total force in the X direction, which is this way, I can go ahead and set that up. I could, if I'm concerned with the entire geometry, I could pick everything. If I'm concerned with just one body or face, I can pick just that. So lots of control over what you're trying to study. Oops, I did face. I want to do all faces of a body, and we'll grab all those bodies there. And so here we can see that transient simulation going. And there's a lot of great options, like I could set an end time, so it just stops at a certain time. Here I can turn on this time average display, and you'll notice that it just helps remove these really high oscillations that don't get you a good idea of what the average value is, so I can start to see that trend through there. So I would definitely explore the Discovery Live external arrow, especially for your models. But before we take a look at that, I do want to show some of the simplification and pre-processing that SpaceClaim offers. So, here I've loaded in, this is a SolidWorks assembly, but this could have been opened from a Parasolid file or a step file, and notice that it maintains the same hierarchy, so very easy to work with the assembly structure. And for whatever reason, the track here is, here's our 0, 0, 0, and our pod is over here at a distance. Not sure why, but it doesn't really matter because you can easily change that. We have the move tool. The move tool I was showing previously using to move faces, but you can also move bodies. I don't want to move the track, so I'm just going to shift select the top one, shift select the bottom one, just like in Windows, another Windows shortcut that we stole. And so all of those things are selected, and I want to move them up to the center of the track. So I'm just going to pick that blue direction, pick the up to button, pick a face, and it's going to take 150 bodies and just move that over. Was it SpaceClaim's issue? Was it something in SolidWorks? Is it something not related to either? Who cares? Very easy to go ahead and just make that kind of change. Also, this model, the design was updated, and it originally had this fairing here. By the way, drag and drop to open. You can do file open just like in any program. And if you want to open a non-SpaceClaim file, all you do is pick it from here, or even pick all files. You can basically open up almost any CAD file in SpaceClaim or Live. SolidWorks, Solid Edge, Creo, Inventor, CATIA, Unigraphics, a lot of different programs, and also your generics, IGES and STEP and Parasolid. Believe it or not, a lot of the models that are used either by myself or colleagues or even in tutorials online is from this webpage called GrabCAD. If you have not been here, I highly recommend checking it out. All of these models can be downloaded, imported, and edited inside of SpaceClaim. You can simulate them, you can change them, borrow some ideas, try some things out. Why reinvent the wheel if someone already invented it? So this is a great resource for models that can be imported and edited right here inside of any Discovery product. But here, I want to add this Parasolid file, so I'm just going to drag and drop it right here into the design window, and that's going to insert it in. So SpaceClaim is kind of like a melting pot of CAD. You know, it's really easy to, you know, bring things in from different file formats, just move them around to change where they are. I can also work in a cross section. So let's say I select this space here. There's a mode called section mode. It puts a slice through the model here, and so if I want to, you know, kind of look inside of this as I move it around, now I could do that. I can grab it from the tree here really easily and go ahead and move it, you know, wherever I see fit, you know, making sure that this snaps. But, you know, let me go ahead. I'm just going to move our grid in a little bit because the area that I'm concerned with, you know, fitting together happens to be right over here. So we're just going to look at a cross section like this. So, you know, I could see here that I really need this face to snap up to this face. Now, I have options. I could edit the geometry. If I change where that face is, you know, we're still not good at the end here. Obviously, it's not in the correct position. So I want to move the entire model, so we'll select that there. And what's great about the Move tool is you can put that move handle wherever you want. We did this in the other model, and I could do it on this imported one. I could put it right on that edge, and I could say that I want to move it in this direction up to this edge over there, and those have been snapped together. I could go ahead and look at the other end of the model, and I could see that, all right, well, you know, maybe it's not the exact same size, but I could change that. I can use the pull tool. I could just grab that face and drag, and, you know, maybe if I needed some clearance, I could just drag it over there. Or if I wanted it to be exact to that face, I could say up to and pick that face there, and it's going to snap. And one thing I want to show you is it went from being a planar face. This is a planar face right now, but the mating face here is actually cylindrical, and that, you know, that change happened. It took this planar face, and it pulled it up and made it a cylindrical face. So now we have a face-to-face fit. If not, we do have an option where we could pull it up to, and instead of selecting the face there, I can select, let's say, this point, and now it's going to be a flat face to that point. So again, by interacting with the model differently, by pulling up to a face, it matches to that face. But if you pick just that point on the bottom here, it will just snap it to that point. So depending on what we want to do, we have a lot of different options. So pull is a great way to change the model and allow you to reuse something when you make changes. But there may be another option, and I'm just going to hide our main track here for a second, because, you know, even after making that change, there still may be some interference. There's actually, you know, these parts here are still overlapping. Now, I could change it in a different direction. If I select this face and go into a section that way, you know, this face is right there, and I could go ahead and, you know, pull that down if I wanted to, so that's always an option. But there's another completely different tool that will allow us to do this, and this is our combine tool. So this basically does Booleans. If I want to cut our housing with this frame here, I can do that. Basically, the tool wants me to select a target to cut. Now it's telling me, by the way, I've got this message here telling me what to do. So it tells me to select a cutter object. That's going to be this one right here. And now it says click a region to remove. This body, notice it's been trimmed, and this is left over, and I can either click to remove it, or there may actually be a number of pieces, and I could always drag a box around where those pieces are, and it will delete them. So if I were to say hide this, that cutout's been made down to there and along wherever we need to go. Now over here, it didn't make the cut just because it's a different body. So I could do it manually here and say combine, cut this body with this piece, and then get rid of that interference. So it's very easy to either pull to make edits or combine to make edits. Combine does all of our Boolean, whether it's cutting bodies or merging bodies. I could say that I want to take this body and merge it into that one. It's just a matter of holding control. You'll notice the combine tool says, as I'm using it, press control to select to merge. So this message right here can be very useful in just knowing what the tool is expecting from you. So, that is some of the pre-processing and the geometry editing that, SpaceClaim can do here. But it can really be a lot more powerful than that. So what I want to do now is I just want to focus on, say, a sub-assembly for a minute. And there's a really easy way to identify sub-assemblies in a model. If I select this face right here, there's a parent-child select. And if I hit the parent button a few times, it goes from the face to the solid to the part to the sub-assembly. And with the sub-assembly now selected, I can right-click and hide everything else. So even though those other parts are still part of the design, simply by hiding them, everything is going to be quicker because SpaceClaim only operates on what's visible. So in looking at this subassembly here, keep in mind, if I want to make changes, very easy to do. I can pull on one face and extend it that way. I can double click and grab those faces and notice this whole thing is either offsetting to thicken or thin, whichever way I want to do that. Or, maybe I want to, make it taller, make it shorter, whatever kind of changes I need. So this model is just as editable as anything else, depending on what kind of things we want to change. But, in looking at this model, I don't know how common this is, but I see a couple parts that I can see through. And, usually that indicates some sort of an error or issue, because when we, simulate these, we're looking at these things as solid bodies. If I go ahead and I, find this body in the tree, it's actually a surface body. And surface bodies, usually if they're surfaces, they're going to be shell elements, which I don't think these are. So if these are supposed to be full-on solids, we need to fix that. So there's a set of tools in our Repair tab designed to solidify surface bodies. If there are multiple bodies that we need to join together, the stitch tool will do that, and it actually found some. These edges are not joined together into one body. If I were to find this in the tree, oops, we found it up here. We just need to stitch these together. That's why this is a surface body. And after we run gaps, or stitch, we may look for gaps and there are none there. But the problem that this model had is there's a number of faces that happen to be missing, like the ends of holes for some reason are missing in a number of areas. So this found 67 missing faces, which are making these things not solid bodies. And by clicking the check mark, it's going to put those missing faces back in. And once a surface body is a complete closed body, it automatically converts to a solid. And once it's solid, it automatically turns opaque. So now these are meshable and ready to go. So, oftentimes models that we import in or get from suppliers are corrupt, and this is a great way to be able to fix them. Now, on a model like this, if we're doing a simulation, some of the geometry in here may not be necessary, and in fact may be preferred to remove. For example, rounds. I don't like rounds on a model. They often do not improve the simulation, but they just make meshing really slow. So fill is a magic eraser. If I have a face selected like this round and I click fill, what fill does is it deletes the face and extends the neighboring faces until they meet. So you can imagine that this face here is surrounded by this face and this face. So when I select this round and click fill, it extends those to a sharp. You can do that for rounds, and you can even search through the model for rounds of a certain size. So if I select this round and go to this selection panel, this panel is kind of like a Google search. It could find rounds equal to the size, equal to that size or smaller, and right now it's only searching this body, which is a good starting point. So with a couple clicks, it selected 30 different faces of rounds, and the fill tool is going to go through and delete those faces and attempt to create sharp edges out of them. Now, sometimes the geometry can be pretty complex, and it may have issues doing so. Sometimes we just need to give it some time, and you'll see that it was able to remove some, but not others. The main reason is when they intersect. Sometimes it can't figure out intersections like this. So we have a dedicated tool to help with round removal in this scenario. It's called rounds, and what you're able to do is click along the edge of a round like this, and it breaks it up. The reason for doing this is if we can isolate groups of rounds into manageable sections, we can then attempt to remove them. I'm going to break this one up here and remove that section there. And now I'm going to take this section here and fill that in. So it's kind of like divide and conquer. When all of the rounds cannot be removed in one shot, we can go through, and this process we call venting. We're breaking up the rounds. And then once broken up, I can box select around this whole area. So box select is a very powerful selection technique in SpaceClaim. You know, you don't want to have to hold control and click all these faces to select them. I would rather drag a box by holding down the mouse, and it selects everything in the box. Be careful though, because if you drag from right to left, it will select anything the box touches. So here I can box select here, and then F for fill, and start to further, you know, simplify this model. And then we'll attempt to do all of this in one shot here. Wasn't able to do so. So again, you know, we can further try this venting process. But you know, I do realize with the clock here that, you know, we are coming up on the time. So I want to move past the round removal. You kind of saw how that process can go, because another thing which can complicate meshing are holes. Maybe I don't want holes in the model. So if I select one and fill it in, F for fill, it removes it. But I can also search for holes. If I want to grab all the holes of a certain size, I can search all bodies, easily grab all holes equal to that size and smaller. Now, some of these holes I may want to remove, but other holes I may need. So this is just a starting point. If I hold Control and I do another box select, it will deselect what's in that box. Now I've got 49 holes selected, and we'll hit F for fill, and it's going to go through and remove them. If there's anything like these little dimples that I don't need, I could just box select around those and fill those in. So really easy to clean up and simplify the model. You know, same thing with these holes here. But with these, you know, I might want to search for something like surface area. There's a variety of things that you can search for. May not have the same area, so we can always add to the selection in order to simplify correctly. So I could just go through, I'm holding Control as I box select, and if I accidentally over select, I can deselect that as well, and that fill tool is going to remove all of that detail. So if we want to simulate these as solids, we're probably ready to go. And the one extra thing that we may want to do is share topology. You know, this large face right here is going to transfer loads to this smaller one, but there's no matching face to do so. In order to have a matching face, we just need to use share topology. By turning on the share button, it's going to look for faces that are mated up like this, and it's going to highlight them through the model. Now, here there's actually some interference, so we might need to do a combine and cut one body with another in order to try to remove that. Another option with shared topology is we could also try to force it. But the last thing that I wanted to show here was, you know, in order to simplify a simulation like this, instead of running it as solids, we can also extract mid-surfaces and run it that way instead. So we have a great tool for mid-surface extraction. I can start by picking, you know, pairs of faces on the model, and then I can basically use a range. Through the model for bodies that have a thickness within that range. So instead of simulating as a solid, I can extract shell elements or mid-surfaces that are 2D, in fact, and that simulation will take a lot less time to run. So this is going to go through and extract there. As this is thinking, I also want to show that we can do something similar for beam extraction. I'm just going to show this on a different model I have here. So mid-surface extraction is a way to simplify solids into surfaces, while beam extraction is a way to simplify solids into line elements or beam elements. So on this mid-surface, I'm just going to hit the check mark, and we'll see how that extracts. And so you can see this process running here. I'm actually going to load up another SpaceClaim for the beams. By the way, if there's any questions, please throw them into the chat panel. Don't see any yet, so just going to continue showing until I run out of time here. What's great about mid-surface extraction is that it does some automatic extending. What I want to show you here is that if we look at this mid-surface that it extracted out of here, you'll notice that they still meet along an edge. But if we were to extract this piece individually, it would end down here. So automatically there is a good amount of extending of the extracted mid-surfaces. And if I click in white space here, here are those mid-surface bodies. You know, these have thicknesses as properties. You'll actually see way down in the structure tree, you know, these mid-surface bodies right here. It has a mid-surface property. This is something that you can run an optimization study on through Workbench and Mechanical, and it's going to be much quicker than when you do it to a solid body. Last but not least, I want to show the same thing for beam extraction along with some of the beam cleanup that we can do, because, you know, when you extract beams from a model, you know, their endpoints may not match up perfectly. So I'm just going to go ahead and hide some stuff here. Actually, so one thing you can do is hide things. So right-click, hide. There's keyboard shortcuts like Control-H. You can box select things and hide, and so we can reduce it down here. I've already done that some. There's a number of parts that we need to hide, so I've hid them and saved it, and I'm just going to reload that here. So the same way that I was extracting mid-surfaces from the model, I can also extract beam elements. The beam elements are going to save the cross-sectional profile, and so all I have to do is turn on this extract tool, and notice that if I click one beam element, or one solid, I get a beam. If I drag a box across a few, it'll do those. So one method is to select everything. If I were to go through and hide everything that wasn't a beam, I would box select everything. But because there are so many more other elements than beams, it's going to be a little easier to select it this way. Now, I should have hid that fairing on the side here. It's trying to extract from the fairing, which it obviously cannot do. So I can continue to go through the model and extract the rest, but what I want to do is after it does this last extraction, I want to show you what the cleanup is like, because oftentimes the nodes at the end do not match up, but we have tools to connect them or extend them, and that is going to really help there. So I'm actually going to load this model. Oh, here we go. So here it's been extracted, which is perfect. Now you can see here, if I zoom in, the ends of these beam elements are not on one node. That's the problem, but not for the tools that we have. So one tool to use is connect, and the gap may be bigger than this. You'll actually notice if I measure between these endpoints, it's at about 40 thou, not 4 thou. So I can change these settings here. If I make this, let's just say 0.1. Oh, so we need to use our extend tool, I apologize. With the extend tool here, notice that it highlights all of these, and if I click them, it extends them right to that one node. I could box select a group of them, so if I want to do these 3, I could box select and hit the check mark, and it does all 3. Or I can hit the check mark, and it'll do all of them. It may have to do it in a couple iterations, or there it goes. This can also be done with the and connected to the bodies that are here. So let's say I do a mid-surface extraction on this body. So instead of a solid, it's now going to be a shell element. What I want to do is find, there we go. And then so what I want to also do is extract beams from these elements that connect up to that fairing. Perfect. So now I'm going to just take all of my solid bodies and hide them. And let's just go ahead and show that last mid-surface. So you'll notice that our beam elements are both not connected to each other and not connected to our shell element. But this extend operation does have that ability. Here, it trimmed it back to that surface, and now we could go ahead and trim these, or rather extend these to one point. If there should be that connection like here, that's fine. Or, believe it or not, the move tool that I was showing before on solid bodies and surfaces can also work with beam elements. So if I just want to take those and grab that point, I could move it in 3 directions at a time right up to that point, and now we've got that connection. There, drive it to 0 like that. Not sure why the up to didn't snap correctly, but these are the types of geometry preparation that SpaceClaim offers. The whole idea of preparing a model with SpaceClaim for simulation or meshing is to remove detail, whether that's simplifying from solids to beams and shells, removing detail like holes and rounds, or being able to set up parametric studies on these models.